What's up, everybody? It is still me, your mentor Terrell, and it is time for another lovely topic called C# attributes like a senior. Using a real-world example, I'm going to explain not just attributes and their usage, but also deep dive topics like the role of CLR, Microsoft Intermediate Language, JIT compiler, metadata, and manifest. You're going to build a real-world ATM application using reflection and custom attributes. After watching, you will understand how the seniors use reflection and custom attributes in their practice, the internal structure of assembly file, the internals of compilation process, and the role of attributes in C#. Well, let's talk about what we have in our agenda. We're going to talk the compile process of .NET applications, particularly CLR, Microsoft Intermediate Language, and JIT compiler. We'll learn a lot about assembly internals like metadata, intermediate language, and manifest. We need to understand the later dynamic binding. Actually, I'm not going to talk about it. I have another topic related to the reflection and interfaces. You can learn later binding from this tutorial, but to handle all the cases related to reflection and attributes, you need to understand what later and dynamic binding is. So, why attributes? We'll learn a lot. Why attributes? Why actually we need attributes in our practice? And at the end, we're going to develop real-world ATM application using object-oriented programming, attributes, and dynamic binding, actually. If you have theoretical understanding of attributes, reflection, and all the things mentioned here, you can directly switch to the real-world ATM development using attributes. If you have enough theoretical understanding related to reflection, attributes, and all the things mentioned here, you're welcome. You are okay to directly switch to the practical section. But again, my option is to watch this video from start to end to not miss any information. So let's get started. Before diving into details, let me show you what we are going to build at the end. We are going to build ATM application. This ATM application will use Windows Form and WPF as a UI, and this Windows Form and WPF application are going to have exactly same UI and same functionalities, but we have technology-based differences, and I will show you how senior developers try to write a code to make it reusable from different technologies. Also, we are actively using attributes and reflection. For example, in my case, let me run our Windows Form application. In our Windows Form application, same is applicable for WPF. We have two buttons right now, add and zero and private NM bank. They are actually assembly files, and system scans the assembly files and draws a UI for us. And we are storing all this information in our libs folder. If you go to libs folder, remove any of this library from the folder, and you run your application, system will able to continue working because we are using reflection and attribute to get all this information to draw the button. We are not just drawing it, but also we have active functionalities like checking the balance, add to balance, and using attributes and reflection. It will be possible for you without changing main source code to extend your application. It means you're able to add third, fourth, fifth providers to your application without changing any line in your application. Let's talk about the compile process of .NET application. In our diagram, we have the full flow of compilation process. When you write your C# code and build your application, our C# compiler takes care of converting our actual object-oriented, the human-based language information to lower language called Microsoft Intermediate Language. The synonym for it is Common Intermediate Language. So Microsoft Intermediate Language is a mediator between our languages. We have high level, more than 100 languages in .NET platform. For example, we have Visual C#, Visual C++, or F# or etc. And all this language compiler will compile their code to Microsoft Intermediate Language. And it helps us to bypass the bridge between these languages. So it is possible for you to write one part of your application in C#, another one in F#, because they are compiling into intermediate language. Okay, so let me show you how intermediate language looks like. So in my case, I'll just, for example, select the Windows Form application here. Let's go to bin, debug, .NET 8, and let's run our developer command prompt. And let's run our intermediate language disassembler. This is actually LDASM, okay? And let's just move the code bytes WinForm DLL to our intermediate language disassembler. In this case, we have the Windows form here. For the Windows form, just select any of these functionalities you want to see, and voila, this is our intermediate language. Okay, let's continue with our presentation, okay? And in our presentation, we have a CLR that already triggered when we run our application. I will dive into details, but for now, just understand that we have CLR that triggered by operation systems process pointer. And in this case, the CLR will take care of our intermediate language data, okay? And inside CLR, we have one component called JIT compiler, just-in-time compiler, that is responsibility of getting Microsoft Intermediate Language code and compile it to CPU-based native language. Want to learn more? Okay, the brief explanation. When you start your .NET application, the operation system's process loader is invoked. So process pointer, process loader, you can call it whatever you want. And the responsibility of process loader is actually to load executable files into memory and initiate their execution. The process loader examines the file format of executable. It recognizes .NET application based on a specific headers and metadata within .exe and DLL file. Actually, we have assembly files, and it doesn't matter if you are building DLL file or exe file, they are actually called assembly files. And the responsibility of operation systems process loader is actually to check if everything is okay, to check if it is the real .NET assembly file using specific headers and metadata. And once everything is okay, it triggers CLR, Common Language Runtime, and then CLR is loaded. The process loader hands over control to CLR's entry point, and the CLR takes care of the rest of the things. And we have loading necessary assemblies. These are actually our responsibility of CLR. 1. Loading necessary assemblies, JIT compiling code, managing memory, handling exceptions, enforcing security, and providing other runtime services. So far, so good. So let's try to understand the assembly internals. Our assembly file, actually the DLL and exe files we created, they consist from EL code, manifest, and metadata. So EL code. EL is an intermediate language, so the core of an assembly containing the compiled code in language-independent format called Common Intermediate Language. We learned that we have C# compiler and we have object-oriented C# code, and the compiler compiles our code to intermediate language. We are not running this intermediate language directly to the CPU. Instead, we have a middleware called JIT compiler, and JIT compiler compiles our code into CPU's native language. So how about manifest? Manifest is a section of assembly that acts as it is table of contents, providing essential information about the assembly itself and its dependencies. In our manifest, we have information about assembly name, version, cultural, security permission, resource embedded within the assembly, strong names, list of reference assemblies, and etc. And the metadata, a detailed description of the types, all the information, all the, let's say, when you're working with attributes, custom attributes, when you create your attributes, all the information will live in our metadata. When you build your application actually consists from multiple types, like the classes, interfaces, structures, enums, attributes, etc. So we have metadata that stores all this information with more detailed data like methods, properties, fields, and other elements. The CLR uses this metadata extensively for various tasks. So let's see what type of tasks we have. Type checking and validation, method invocation, reflection, object layout in memory, code generation tools, and debuggers also rely on metadata. So let me show you all this stuff. I'm just going to use intermediate language disassembler in my case. Again, ildasm. Okay, let's open it and let's go to our project, Windows Form project, open in File Explorer, bin, debug.NET 8, and let's just move our Windows Form application, and voila, we have manifest here. So as you can see, manifest store all the information related to the public key versions of assembly files. We have another module type of information and etc. So all the things mentioned to manifest, you can see here. And when you go to view meta info show, you will see all the metadata information. So here we have custom attributes. I use it in my application. We have all the functions, fields, and types, and all the things related to the types, their properties, methods. All things live in our meta information. And using reflection, you will take information from this metadata. Okay. And as I showed before, we have intermediate language code that is used by JIT compiler to compile to CPU's native code. Okay, now let's talk about attributes. Why and where we are applying these attributes actually. So the purpose of attributes to add them to the metadata and then using reflection, grab this information from metadata and apply build logic around them. So actually, that's how we are using attributes. We are using attributes to add descriptive information to the code elements actually without affecting their behavior. For example, create any method, just add obsolete attribute on it. So you will see that you are not doing any additional logic inside your method, but it is possible for you to somehow add descriptive information to your method. Okay, so we are using attributes to modify how frameworks and tools interact with code elements. So for example, we talked about async state machine attribute. If you want to dive into details, just check my video about that. For example, we have serializable attributes, conditional attribute. This type of attributes actually helps us to modify how tools and frameworks interact with the code elements. So the next is actually reflection and dynamic features. For example, discover and utilize code information at runtime. You can use attributes, XML element, data contract. You can create your custom attributes to match this functionality. We are building aspect-oriented programming elements inside our applications using attributes also. So for example, for logging, for security purposes, you can build your own or you can use built-in attributes for that purpose. If you write unit tests, you have seen a lot of attributes like test method, test category, inline, fact, theory. This type of attributes actually helps us to write unit tests, to build unit test structure. For the web development perspective, for example, specify routing actions with route attributes, control input validation using required attribute, and for the validating data and controlling model binding, we can use required, max length, range, or any other custom attributes we develop. So actually, we are using attributes in any type of .NET applications, like doesn't matter if you're building mobile application, web application, or desktop application, we are using attributes approximately everywhere in our development process. What we are going to build, as I mentioned, ATM application. This ATM application will have two interfaces, Windows Form and WPF. They will have completely same UI, completely same functionalities. And to make the functionalities not to be duplicated per technology, we will use a shared library, a common library for Windows Form and WPF. The purpose here is to extend our application using attributes and reflection. It means using later binding, and we'll build one single core application. And in the future, when we add providers to our system, there will not be any need to do changes in our system. So we are building one time a code base, and meanwhile, when you are adding providers to the system, there is no need to add even one single code line or change any code line in our system. Okay, this is our interface-based decomposition for our system. We implemented this functionality from scratch. We implemented this ATM system from scratch in our interface video. Just check it, because I'm not going to implement everything from scratch for attribute-based implementation. We already have a code base. The only thing I am going to do here is actually to replace our iBank provider to bank provider and bank operation attributes. And the related changes will be done in our providers and also in our decode bytes common to make these attributes workable. A small note for you: if you want to follow me along the coding process, just go to the first branch, download it, and follow me along the coding process. But if you don't want to follow me, but just to download and check what we did, just go to the second branch and work on it. Oh, it is time to build our application. So this is my master C# interface, is like senior branch. What I am going to do, I'm going to create another branch from this branch, because I'm going to use the main structure from this application. Attributes like senior. So we have completely same structure as in our interface implementation. If you want to learn more about this project and also about interfaces with reflection, you can check my video about it. For now, I'm going to replace our iBank provider with two attributes. So iBank provider is actually a real mediator between our code structure and providers. We are providing this interface to our third-party libraries, to our clients to implement it, because our application by default supports only those classes that implement iBank provider. This is our main contract. So I am going to break this contract actually and replace it with attribute. Let's right click, add class, bank provider attribute. Cool. I will not create attribute from scratch, because we have in Visual Studio a good code snippet that helps us to create an attribute. In my case, I will use the name bank provider attribute. So when you create an attribute, you should inherit from attribute class. And also for attribute, we have attribute-based declaration called attribute usage. The first argument indicates that what type of elements do we want to apply this attribute. I want it to apply for my classes. So I will use bank provider attribute only for my classes. There is no possibility to inherit from this class, and I don't want to apply multiple bank provider attribute for the same class. So for that reason, I'm using allow multiple false. What I'm going to do actually to remove this, let's put public, and here I will use string provider name. So let's remove all this structure from here. What I am only going to do is providing public string provider name that will return that will return our provider name. Get, okay, get, return, provider name. Well, that's actually all about our bank provider implementation. So a purpose here is, instead of using a bank provider, use bank provider attribute. But that's not all, because we have also operations. So we need to somehow mark our operations using attribute. For that reason, I am going to create another attribute here, and it will be called bank operation attribute. And for bank operation attribute, I will have enum bank operation type, and we will have add to balance and get balance attributes, get balance values for our enum. So let's just use it. Bank operation type, and operation type return bank operation type. Actually, that's all. The real two attributes in this case will match the only interface we implemented before, iBank provider. After removing iBank provider interface and replacing it with bank provider and bank operation attributes, now it is time to apply these attributes to our providers actually. Let me just remove unused namespaces from here first. And let's go to our providers. For example, first Eden0 provider. Now we don't have iBank provider interface actually. Let's remove it. And let's annotate our Eden0 provider with bank provider, and we'll use provider name Eden0. We have provider name from bank provider attribute, so there is no need to have provider name property here. Let's remove this. Okay, and let's do read only here. And let's go to our add to balance and mark it bank provider. The bank operation and bank operation type dot add to balance. And let's go to the get balance and make it get balance. The only thing we are missing here is actually we haven't changed our attribute targets class. Let's replace it with method. Now everything is okay. Cool. Now let's apply it for the private NM bank. So as you can see, it is really easy in our case to replace interface with our attribute. Private NM bank will use reflection to read the bank name, also the operation type. The bank operation type, the add to balance, and let's use it for the get balance also. Let's build our application and see what we are missing. Actually, we have iBank provider in our code side. We need to replace it with our interfaces. So in this case, we don't have iBank provider interface. Actually, we need to implement a better way than using iBank provider. Instead, this is not a better way actually. We should implement the mechanism that matches to our attribute. Now we don't have iBank provider. We need to replace it with another implementation. We'll do it a little bit later. So we don't have iBank provider as interface here for the get providers actually, and we need to replace this implementation also. Well, let's implement our provider service. This provider service is actually a main component that will be used by our WPF and Windows Form application. We are encapsulating all the logics related to reflection to provider service, not to spread the reflection logic between our UI components like WPF and Windows Form. For that reason, we have here get interface method that checks our interface. If we have this type of interface implementation, we are doing for each, and using yield return, we are returning the instance of iBank provider. Actually, in my case, I don't have iBank provider. I have custom attribute. For that reason, I'm going to use get custom attribute, and we have generic mechanism here. I will use the bank provider attribute here, and I will check if it is not null. Okay, so that should be enough to get our implementations for the bank provider. And now we have all the providers we are doing for each year. What I'm actually going to do, we don't have iBank provider. We are not activating the instance of iBank provider. Instead, I need to get first provider name and then all the attributes in our methods like add to balance and get balance. For that reason, what I'm actually going to do, I want to use activator create instance first to have an instance of the element, because I will use a delegate based mapping mechanism from our reflected information to the wrapped class. Let's go for it. Object instance. I think it is nullable. Yeah. Now I need to get my methods as a method info. For that reason, I'm using var add to balance. So from the provider type, I will get all methods. Actually, these methods will use binding flag instance and public, and then first or default x dot get custom attribute. What type of attribute I'm looking for? Actually, I'm looking for bank operation attribute. Bank operation attribute here. And for the bank operation attribute, I will use operation type equal to operation type add to balance. That's how actually I'm getting add to balance method. The same is applicable for our get balance also. So let's replace it with get balance. So here, let's use get balance. Now we have the get balance and add to balance as a method information. Now I need to get a delegate from this information. Why delegate? Because instead of using a bank provider to the higher layers, I will provide a separate class called bank provider. I can actually use abstract class or even interface in this case, but to wrap all this instance with their method info using delegates, I will use bank provider with string and 2 delegates in it. So let's go for it. Add class bank provider. In my bank provider, I will have public string provider name get init. It is actually, let's use required in this case, okay? And I want to get my add to balance and get balance as a delegate. For that reason, I'm going to use public action card number decimal. This is our add to balance. Add to balance get init. This is also going to be required. And of course, for the get balance, we'll use func card number decimal. Why? Because in my case, add to balance for my all providers, it has 2 arguments and it doesn't return any value. So we already know from our delegates lesson. If you don't know about delegates, just check my video if you want to learn more about it. So if you are wrapping your method to delegates, you should check your signature. In my case, this is not returning any information, so this is action and with 2 parameters. For that reason, I created action with 2 parameters. The same is applicable for the get balance. We are wrapping it to the delegate. This delegate will return value. So this is func rather than action. And we're using the card number as an argument here and decimal as a return value. Now, instead of using some type of inheritance mechanism, instead of using a bank provider, we are wrapping all our instances to bank provider. So high levels will see only bank provider in our case. Okay, let's go for it. And what I'm actually going to do, I need to get a delegate from add to balance and from get balance. So delegate, create delegate. The first, I'm going to create a delegate for func card number decimal, will return card number decimal, and we'll use our instance here, and we'll use add to, I think it should be get to balance. Yeah, get to balance. This is our func delegate. I'm using the func delegate actually here. So it is type. This is actually our type of. Okay. So let's use it here. This is our delegate var get balance delegate. This is our get balance delegate. And I know this is not nullable in my case. I'm just copying it from here and using the action, I will build a delegate around add to balance. Cool. Now we also have add to balance delegate here. Cool. Now we have add to balance, get balance with get balance delegate and add to balance delegate. Now it is time to return our instance. So return new bank provider. And for the bank provider, add to balance is going to use add to balance delegate. For the get balance, we'll use get balance delegate, and for the provider name we'll use our it will be our provider name. Let's just hit the pro. So the add to balance action. Okay, so add to balance, it should be actually action. Let's do a little bit of refactoring and correction here. So let's do in this way. And Control key D. Okay, and for the get methods here, we have some duplication. So I am going to use method extension here because why method extension? In this case, this is a project-based implementation. Only in this project, I will need the bank operation type of searching. So I'm going to create extension here, right click, add folder extensions, and right click, add class type extensions. So for the extensions, we need to have a static class and public static. Let's wait for now. And this is going to be get method this type, bank, operation type, bank operation type, and let's return the values we need here. We are returning method info in this case. Let's change it to method info nullable. Okay. And let's just copy this information from here and paste it here. And for the type, we'll use provider type bank operation and replace to the bank operation here. Cool. Now we have method extension and let's use it. Just make it get method and bank operation type get balance. Cool. Let's just copy and let's do the same operation with add to balance. Cool. What else we are missing here? Of course, we need to provide the exact provider name. How we are going to get it? Provider type get custom attribute. In this case, bank provider attribute and provider name, otherwise unknown. Cool. Everything is okay for now. Okay, and let's replace our iBank provider with bank provider in this case. Cool. And let's go for iProvider service. Let's replace iBank provider to bank provider exactly. And let's remove this unused namespace. So let's go for bank provider. It should be public to use outside of the given assembly. And that's actually all about provider service. Okay, the last thing in our application is actually to make our UI applications, in this case WPF and Windows Form, workable. So let's try to build our application. We'll get some exception because our UI elements like Windows Form and WPF are using iBank provider. So let's go for it. I will change our visualizers. In Windows Form and WPF, we have technology specific visualizers. Actually, they are wrapper over our provider service. So let's go for it. In this case, we are not going to use the iBank provider. Instead, we are going to use bank provider class. So it is public. Okay, let's go for bank form, and let's replace bank provider, iBank provider with bank provider class. And that's actually all. And let's go our WPF application and do the same changes here and go to bank window, replace iBank provider interface here and use the proper namespace. Well, let's rebuild and see if building is succeed or not. Cool, everything is working. Now it is time to check the application. I'm just going to copy, for example, Eden 0 bank provider. Let's go for it. Bin debug.NET 8 Eden 0 provider. Let's copy it and paste it to the Windows Form libs folder. Right click, paste. Right click, paste for WPF also. So let's run our WPF application to check if everything is working. It should show Eden 0. Cool. And let's use 111, 222, 333, and 444. We have 500 balance for it. Yes, it is working. Let's add 590 and let's check. Cool. Everything is working. And let's go for private NM bank. and bin debug.net private NM bank provider. Let's copy this and paste it to the Windows form. For instance, let's set it as a startup project. Let's run it. Let's check these providers. Eden 0, 111, 222, 333, 444. Let's check balance. It is working for Windows Forms also. Let's add and check. Yes, everything is working. For the private NM, let's see what we have as a default card number here. Okay, let's go for it, paste it, check. Yes, it is working. Let's add 400, check. Now everything is working. Well, that's almost all. This is the end of the attributes journey. If you like my videos, hit that subscribe button to be the first to see what is next. Let me know you were here with a like. Share it with others to help them to grow their knowledge. I'll see you in the next adventure.